So, a rifle recoils while firing a bullet. The impulse that acts on the rifle. Okay, the way we want to complete this sentence without looking at the multiple choice, the word we are looking for is equal and opposite. Let's be clear why. So, there is a force on the rifle due to the bullet. And by Newton's third law, there's an equal and opposite force on the bullet due to the rifle. If we multiply both sides of this by the time that they're in contact with one another, what we realize is that the impulses are also equal and opposite. So what that means is if the impulse, so I'm just going to note that I'm going to write the words equal and opposite. And what I'm going to note here is which of these choices even is in line with Newton's third law, that if A pushes B, B pushes back on A with an equal and opposite force. So not that, not that, not that, not that. Believe it or not, none of these is finally a choice. All right. One ball bounces and another ball the same mass does not bounce when dropped. The ball that bounces actually has a greater change in momentum and a greater impulse given to it. Let's talk about why. So first, let's look at the ball that does not bounce. So it goes in at a speed u, and then it sticks. So v equals 0. Now let's look at the one that goes in at a speed u and bounces back at a speed v. And again, since there's an arrow, that means that there's a negative speed. So let's look at the impulse. The impulse here, mv minus mu, is going to be negative, mv minus mu. When we calculate that, it's just going to be negative mu. Now, if we get the size of the impulse, that's mu total. Now, let's look at this change in impulse if we bounce. So this is no bounce, and this is bounce down here. So we go in, we have a final speed m negative v, having gone in at mu. So the total size of the impulse is negative m, and we factor out v plus u in parentheses. When we take the absolute value of that, mv plus u is our total impulse, and that's going to be greater than the mu up here. So the thing about any concept question is in physics, it's never a concept question. It's always a calculation. So, which of the following delivers the greatest impulse? 1 kilogram lump of clay that sticks to a wall, one that bounces, both deliver equal impulses. Nope and nope. It's always the one that bounces that delivers the biggest impulse. That's actually a good takeaway for both these questions. If you're not clear on the logic, a good thing to memorize to take to your next physics class is the one that bounces has bigger impulse and delta P if U and M are the same. All right, so next we'll take a look at question number 6. An egg hits concrete and breaks. Another identical egg dropped from the same height hits a trampoline and bounces back at the original speed it was hit with. It doesn't break. Which egg has a greater impulse and why? Now here's the interesting thing. Impulse is different than force. I absolutely believe the egg that hits concrete has a bigger force, but it has a smaller impulse. So this is false. This is also false. C is the only statement that's true, but let's get a little bit deeper. So here's a question a student might ask. C is, C, sorry. So let's just be clear here. C is true. But why, if the egg breaks on concrete? So let's be clear. On the concrete, I may have, so here's what we'll do. We'll compare the concrete to the trampoline. Okay? So on the concrete, I have a very huge force over a very small amount of time. And that can be a smaller impulse than a very small force over a very huge amount of time. So in other words, there may be more impulse for the trampoline, but all that's happening is on the trampoline, there's a smaller force over a much larger time. And that's the idea. The time is so long for the small force that it ends up being a bigger change in momentum, even though the other one has a big force over a small time. It's the product of the force and the time that's bigger. All right, so that is the second page of the practice test.